we're recording now, right? I already told my joke of the day, so I don't have to waste time with that. So an identity, okay? What is an identity? An identity is an equation that's true for all values in the domain of a variable. In the domain of a variable. So basically, when you're doing identities, you're trying to show that the left side is equal to the right side, or the right side is equal to the left side. Some strategies to working with identities is work with one side. Work with one side at a time. One side. So it's kind of, in the book they actually say work with both sides. Don't do that. Just work with one side. Really what you're trying to do is get the left side equal to the right side, or the right side equal to the left side. If you work with both sides, then it gets really confusing. A, for me to follow, and B, for you to kind of figure out where you are with the identity. So work with one side, and usually the more complicated one, okay? Usually the more complicated one. Complex. And then what else should we know? So some strategies for working with identities are to factor, okay? Add fractions, which usually involves finding a common denominator, okay? You need common denom, which is, we've already seen some of this in last night's homework. Sometimes you have to square a binomial. A binomial is another strategy, which we'll see. And use identities. Use fundamental identities. And change everything. And sometimes, like I tried to do that in the last problem, change everything to sines and cosines. And cosines. And then if stuck, try again. Okay? So sometimes you will try something with it. So you're trying to get, they're like little puzzles. I like them because they're kind of fun. But sometimes you'll be trying to get the left side equal to the right side, the right side equal to the left side. To say, oh, I'm not going anywhere, maybe I should try something different. So you'll like kind of get stuck in the middle and nowhere. You say, I don't know what to do. Try something else. Maybe try working with the right side, or maybe try factoring, or maybe try, like in the last problem we saw, I shouldn't have changed that one to all sines and cosines. Okay? So, so here's some examples. And we're just going to work through some, and then I'll give you some time. Hopefully we'll have some time to work. We'll see. Verify secant squared theta minus 1 divided by secant squared theta equals sine squared theta. Anyone want to guess what to do with that? Trent?
Change secant squared theta minus 1 into tan.
Perfect. Okay? So I say, oh, this is equal to tan squared theta minus 1. One other thing that I thought about doing, I said, well, I could factor this. This is like x squared minus 1. And I could do like x plus 1, x minus 1. But that, when I look at the bottom, I'm thinking that's probably not going to get me very far, right? And so one thing I could do is change this top into tan squared theta divided by secant squared theta, okay? So notice that I'm just working with this side. Then I'm trying to get to here. So what might I try next? Go ahead, Trent.
Change tan to sine, cosine.
Right.
Change tan to
Perfect, okay? So now I'm going to change this into all sines and cosines. So now I get sine squared theta over cosine squared theta. And I could rewrite secant squared theta as 1 over cosine squared theta. And then things will disappear. Do you know that you can do this? Like that? And then you're done, right? That's equal to sine squared theta. If you're not comfortable with doing that, just copy dot flip and you'd be able to do that, right? Flip it over and then you're done with that. Yes? Not that horrible. Was that horrible? Okay. Let's try another one. Oh. Okay, so what if I said, next one, verify that 2 secant squared, we're going to use a different variable. 2 secant squared, what's that thing called? I think that's an alpha, okay? I get confused with my Greek letters. So. Over 1 over sine alpha plus 1 over 1 plus sine alpha. Anyone have any ideas on that one? Which side do you think I should start with, other than Trent? Colton? Start with the right side, okay? Because it looks a little more complicated than this side. Any ideas what I should do with that right side? Right? Find a common denominator. So I'm going to multiply this side, this one, by 1 plus sine theta, right? You can already see, or alpha, sorry. 1 plus sine alpha over 1 plus sine alpha, right? Over there. And I'm going to multiply this by 1 minus sine alpha over 1 minus sine alpha. Okay? And then what I get on the top, I have 1 plus sine alpha plus 1 minus sine alpha. I don't have to worry about parentheses because it's plus. The whole thing over 1 minus sine alpha times 1 plus sine alpha. What's 1 minus sine alpha times 1 plus sine alpha? What's this times this?
Sine squared.
1 minus sine squared alpha, right? Okay, now look at how nicely things disappear. This goes away, because 1's minus 1 plus. This is just kind of like that last thing I did. What's 1 minus sine squared equal to? Cosine squared. And then 2 over cosine squared is equal to 2 secant squared. Whoops, theta, I meant alpha. Okay. Alpha, beta, gamma. I made up a joke about Greek. You want to hear it? I always thought that Greece was in Italy. Is it? No. Greece is in Rome. No, Rome is in Greece, right? But there's a little bit of Greece, but Rome is, wait, I get confused. Oh, where's Rome? But there's a little bit of Greece in Rome because they have pizza there. And pizza's pretty greasy, you gotta admit. I made that one up. Okay, I knew that. I know that Rome is a country. Oh no, it's not. It's, okay, so we're done with that one. Those weren't too bad. So what if I wanted to verify? Okay, we'll do 3 more, then we'll be done. Okay. So what if I wanted to show? Sometimes I'll say show instead of verify, but they mean the same thing. Show that tan squared tan squared x plus 1 times cosine squared x minus 1 equals negative tan squared x. Anyone have any ideas on that one? And so you gotta try different approaches. So you might want to try to multiply these together, but then you're gonna get like tan squared cosine squared. That's gonna get messy. Okay? Which side do you think I probably want to work with? Left. What's tan squared theta x plus 1 equal to? This is equal to secant squared. So this is why you have to kind of know these Pythagorean identities. That's equal to secant squared. This is looking promising. How could I rewrite cosine squared x minus 1? Ella? Yeah, because sine squared is equal to 1 minus cosine squared. So this piece in here can be written as negative sine squared x. Okay, because 1 minus cosine squared is equal to sine squared. So the negative of that, right, would be negative 1 plus cosine squared, which is what this is, right? So this is negative sine squared. Then I could write this as what? How could I rewrite secant? 1 over cosine. So that's secant squared times 1 over cosine squared. And what's that equal to? Negative tan squared x. And I'm done with that. Yes? Verify the identity. 2 more. And we'll be done. So show that verify secant x plus tangent x equals cosine x over 1 minus sine x. Anyone have any ideas what I might want to do with that one? Which side do you think I should work with? I would work, yeah, even though you might be tempted to write these as sines and cosine, I mean, think about it in your head. That's going to give you 1 over cosine and sine over cosine. It might work. It probably will, okay? But I would mess with this side. What should I do to that side? Multiply the top and bottom by 1 plus sine. That's why they give you that first section. It's just giving you some techniques that you can do. So you're going to multiply by the conjugate, that's called, of the bottom. And that will usually make the bottom disappear or make it look nice. So, and the other thing to be careful of on this is do not distribute through that top part until we do something down here, because something's going to cancel out, right? So what's 1 minus sine x times 1 plus sine x equal to? 1 minus sine squared, right? And what's 1 minus sine squared equal to? Cosine squared, right? So I have 1 plus sine x over cosine squared x. And then I could cancel out one of those cosine squared x's. So all I have is a cosine x down here. And then what I do is I rewrite this as 2 fractions. 1 over cosine x plus sine x over cosine x. What's this equal to? This is secant x, and this is equal to tangent of x. And then I'm done. So it's just lots of practice with these. Did I go too fast for anyone? Yes, I went too fast. Or did I go too fast? So this last step from here to here.
Yeah.
So this was 1 plus sine x over cosine x, right? So just if you have like 1 plus 3 over 7 or something like that, I could write this as 1 over 7 plus 3 over 7, right? So I break this apart. So this is 1 plus sine x over cosine x. So I could write this as 1 over cosine x plus sine x over cosine x, because I know that this is going to simplify to that, and that's going to simplify could probably have written this as 1 over cosine x over cosine x, found the common denominator and got it equal to the right side. You could try that if you want. It might be easier. I don't know. Okay. Last one. This one's not too bad either. And we did one like this on an identity sheet way back when. Last one, cotangent squared theta over 1 plus cosecant theta, and they want you equals 1 minus sine theta over sine of theta. So verify. Why would you want to do this? I don't know. Math people are evil. Any ideas? What do you think there, Tenzin? The bottom is in cotangent, okay, but the top, this is a tricky. So I could probably work with this side and do something like multiply by 1 plus sine over 1 plus sine, but I can rewrite the top, cotangent squared is equal to cosecant squared, cosecant squared theta minus 1. Okay? So this is equal to cosecant squared theta minus 1 over 1 plus cosecant theta. Anyone know why I would want to do that? Right. This factors. This is like x squared minus 1, right? So this can be written as cosecant theta plus 1 times cosecant theta minus 1. Okay? And over 1 plus cosecant theta. And these two things are essentially the same, right? See that? Can I cancel that out? Those are the same, right? 1 plus cosecant theta is equal to cosecant theta plus 1. So I can then cross these out, and I get that that's equal to cosecant theta minus 1. I'm still trying to get this to over here. So how can I rewrite cosecant theta? 1 over sine theta minus 1. And if I find a common denominator, right, if I multiply this, negative 1, by sine of theta over sine of theta, then I have it, right? 1 over sine theta minus sine of theta over sine of theta, and that's equal to this. See? Right? 1 minus sine theta, the whole thing over sine. Yeah? No? So they're tricky. There's no like, this is, you know, this one's like this one's like this. You have to just kind of try different stuff and see what works, you know. And if it doesn't work, there's more than one way to solve a problem. Let's just see. I just want to see if I could get to this from this. So what I might have tried is multiplying the top by the conjugate. I just want to see. You don't have to follow. Let's see if it works. 1 plus sine of theta. If I multiply the top and the bottom by 1 plus sine of theta, maybe this will be easier. Okay? 1 plus sine of theta. Okay? Then this on the top, I'd have 1 minus sine squared theta over sine of theta. I'm not going to cancel anything out yet. Sine of theta times 1 plus sine of theta. And then what's the top equal to up here? Cosine squared theta over sine of theta times 1 plus sine of theta. And I'm trying to get to here. Oh look, I'm almost there, right? This can be written as cosine, right? I'm trying to get to here. This can be written as cosine theta times cosine theta over sine sine theta times 1 plus sine theta, right? 1 plus sine theta. So this is equal to cotangent of theta, and this is equal to cosine. I don't know. I'm stifled.
So
I go.
what you can do is you can multiply it out the bottom, right?
Oh, multiply out the bottom.
What's higher?
Cosine theta
One step further up.
up here.
Yeah.
Sine 1 plus sine squared
Because
theta.
you can get the sine squared theta, which would be the cotangent. You have cosine squared over sine squared.
But this is equal to cotangent theta times cosine theta over 1 plus sine
I'm
theta.
confused also.
I'm confused also. I don't know.
Well, that's not a good sign.
So what's sine theta?
So I would just work with the left side. I could probably figure it out, but as you can see, sometimes you get stuck and you go, I don't know, maybe I should switch and work with the other side. I'm going to figure that out right now as you're working on your homework.